Alright, so we're going to talk about how to name acids. Acids and bases. So let's start with the most easiest case. Binary. Binary acids. This means a hydrogen plus a nonmetal element is going to be in the form hydro, the root word of the nonmetal, ic, and acid. So, for example, what would the name for HBr be? You're the only one that's here to answer. What would hydrogen and bromine be?
Is it hydrogen and
So it'll be, yeah, hydrogen and bromine. So it'll be, what would be the full name of it? So we changed the ending to IC and we prefix it with hydro. So this would be hydrobromic acid. What would HCl be? Yes, hydrochloric acid. So we remove the INE off of chlorine and turn it into IC, and we prefix it with hydro. So let's do all of them. So hydrogen and iodine. It would be what? Exactly. And let's do a weird one. These two here I'm going to put on stars. Biome. What about hydrogen and sulfur? First of all, what would be the equation for hydrogen and sulfur?
H plus 1 and S2.
So H plus 1 and S2 negative, and then how would we, what would be the final equation?
2S.
Yes. And what do we name this?
You want to do it with an acid?
Yes.
Hydrogen.
Precisely right. I put a star beside this because that is not the name it's mostly referred to. I really want to illustrate this, that under our current naming scheme, So I'm looking at hydrogen sulfide. This is an ionic bond. So we normally would classify this using the ionic name, hydrogen sulfide. So the systematic name given to it is hydrogen sulfide. But if we look at all the other possible names that can be given to it, you see there is a lot. These are all correct names. Sour gas is a common name, like when we call water water. We don't call it the hydrogen monoxide. So there is a common name for it. There is, this refers to another name, but we see if we were to treat it as an acid, hydrosulfuric, and looking at how I wrote it, it would be hydrosulfuric, not sulfic. So this was technically, yeah, this would be, we add the U and R and IC. Let me just, so H2S. So for sulfur, the IC is attached after the UR and doesn't replace it. So normally this would normally be called hydrogen sulfide. But if we were to treat this as an acid, a proper name for the proper acid naming scheme would call it hydrosulfuric acid. So I want to do another one that again is a little weird. What about hydrogen and oxygen? So hydrogen is +1, oxygen is 2 negative. So what would the formula be? So what is another way we can call H2O? See if I can find the correct spelling of it. Again, this is very strange to think of H2O as an acid. But some proper acidic names would be hydroxyic acid. Another name for this, so some less common ones is hydric acid and hydroxyl acid. These are other naming schemes we will definitely not cover in high school. But the proper way of using this naming scheme would be hydroxyic acid. Again, we call this water. We use the common name to refer to this chemical. But mostly we're going to have just the H and 1. So basically, I will say this we usually call these by their acid names if it's hydrogen plus a halogen. Hydrogen plus a halogen, we usually always refer to it by its acid name. We almost never refer to it by its ionic name. We would never say that this is hydrogen bromide. For hydrogen and halogens, we use the acid name for them. For everything else that is binary, we use the ionic name for it. So this is the one we use for this chemical. So let's look at ternary or ternary. Ternary acids will be hydrogen plus a polyatomic ion. So if it ends in 8, so if it's an 8 ion, we're going to replace or add the ending IC. It depends on the name of it, whether or not we add IC or replace the ending of it. Again, it's whichever one sounds the best. For sulfur, we add IC, and this is best memorized by looking at all the acids and just basically memorizing which ones we are added and which ones are replaced. So for ite ions, we replace it and add OUS. And the word acid after it. So let's do some examples. So H2SO3. What would be the name of that? You don't include hydro. No. So remember, if the name of the ion has an 8 in it, we basically replace the 8 with IC. So what's the name of this one? SO3.
Sulfide or sulfate?
That would be sulfate. No. So you're looking at it wrong. You're looking at the HSO3. You need to be looking at just the SO3. So it'd be sulfite. And if it ends in an ite, we will replace the ite with OUS. So this would be, and again, you don't, on this one, you don't really, this is sulfurous. So in this case, no, I'm wrong. You do not add, you do not replace the 8 with OUS. You add OUS to it. The proper sulfur is weird. I forgot that sulfur is an exception to this. So sulfite, we take the base word and we add OUS. So let's do the reverse. What would sulfuric acid's formula be?
Maybe SO4.
So it would have an SO4, and what would the first part of it be? Just hydrogen? Hydrogen 2. So you need 2 positive charges to counteract the 2 charges here. So it's important to not confuse sulfurous acid with sulfuric acid. Sulfuric ends in IC, so we use the sulfate, which would be SO4. Sulfurous ends in OUS, so we use the SO3. And these are completely 2 different acids. So let's look at H3, PO4. This one is also going to be an exception to the, I guess it's not really an exception anymore. For adding IC and OUS, we're going to mostly be appending it somewhat. It's actually better to almost say, I'll just go ahead and tell you. So, phosphoric acid. So, PO4 is phosphate. And this comes from the element phosphorus. Do I have a periodic table? It's not currently. This is a this is an oxy-ion of phosphorus. And there's no O here. So when you're adding the ic or the OUS, you're going to be doing it from the root word phosphorus. So the US gets replaced with the IC. But when you do 8, it would be also the OR. Which is a weird naming scheme. I'm now actually curious, is it appropriate to spell it the other way? Nope, it's saying most definitely you have to put the OR in it. Is it appropriate to add OR 8? Nope, it says in English that's the incorrect spelling of it. In fact, it completely changes it to a different word. So let's do some other ones. So, what's a good acid? Nitric acid. So if we have nitric acid, what would be the correct formula for it?
Wouldn't you change it back to nitrate?
So the ic, again, ic refers to 8. So yes, it's going to use the nitrate, which nitrate is NO3 and has a negative charge. And so to counteract it, we'd add only one hydrogen to it. So it's HNO3. Here's a tidbit to you. Acids are extremely dangerous. You do not want to get them on your skin, as they'll eat holes on you. They'll melt your skin off. Nitric acid, should you use gloves while handling it? Nope. You would prefer it to eat away at your skin than wear gloves. I will show you a video. Nitric acid on gloves. Most likely, unless you know exactly what your gloves are, this would happen.
That face that is usually
Once
covered by
this
her
goes away.
phone has finally made an appearance. That face wouldn't be doing that if you weren't.
Hopefully this doesn't have bad language. I didn't check
First, I'll
this.
start off with just 2 quick definitions. Concentrated nitric acid is common and available in most labs and is about 68% nitric acid. Fuming nitric acid is not nearly as common and it contains at least 86% nitric acid. First, about 1 milliliter of fuming nitric acid is sprayed onto a nitrile glove, which quickly bursts into flames. And the exact same thing happens with the latex gloves.
The most common gloves used to handle acids
Just
all
for
immediately
comparison
burst
purposes,
into
I will
flames.
show you what regular concentrated nitric acid does on latex. and apparently nothing fun happens.
So
Although
I
he can
would say
visually
if you're
thirst,
not
the
dealing
nitric
with
acid is
fuming,
able to
so highly,
penetrate the
highly
infect skin, so
concentrated, nitric acid, you can wear gloves. But why is that like that? How do I do this? There we go. So it takes a few seconds for nitric acid on your flesh isn't that dangerous. It's not like other acids. Which means there's a good video of it showing what happens nitric acid on skin. Neil Red is a fantastic YouTuber for doing chemistry videos. He basically took and sprayed fuming acid, the more concentrated, onto his fingers, and he stopped whenever it started hurting, and then immediately washed it. That's the key thing. He immediately washed it out and rinsed it off. And his skin got disconfigured as the outer layer died, but overall, it was very little damage to him. Basically, he got blister on his finger, and it didn't do much. So, if you're dealing with highly concentrated, so not concentrated but fuming, certain acids, whenever they get above a certain concentration, they start producing a lot of vapors. It's called fuming acid, and that's not exactly the reason, but it's most of the time you wouldn't trust your gloves because it'd be much easier if you accidentally spill a drop on you. It'll start hurting after a few seconds, and as soon as you feel pain, go start washing immediately. You'll be all right. If your gloves catch on fire and melt to your skin, you have third-degree burns, and you've lost all the skin on your hand as the fire burns away. That situation is bad, whereas washing off the acid is good. Now, for sulfuric acid, which I have in the lab, you will see me with gloves up to my arms, and I know immediately that will eat straight through my skin like a hot knife does butter. So what's some common acids? So nitrous acid. So nitrous is NO2 negative. So HNO2 is nitrous. And let me show you one example with perchlorate. So what would HClO4 be called? So recall that ClO4 is negative and is called perchlorate ion. So in this case, we keep the per, and this just becomes perchloric acid. So whatever prefix, if it's hypo, per, or hyper, the prefix is kept. Bases is much easier. So let's look at a base. A base is a cation plus a hydroxide ion. What we do is we keep the name of the cation and add the word hydroxide. So what So let's do some examples. What would be the formula for Ca plus OH? So what's the charge or oxidation state on calcium?
Plus two.
And OH is? This should be one you most definitely memorize. Negative. Or -1. So what would the formula be?
It would be CA OH plus 2.
So how should we add the two? How do we put? Yes. So we put in parentheses 2. And what would be the name of this?
Calcium.
Exactly right. So bases are very simple. So if we did NaOH, this would be sodium hydroxide. If we did magnesium and hydroxide, we need to double the hydroxide. This would be magnesium hydroxide. So the important thing here is if it's H with an halogen, always use acid naming scheme. Try to find that's not how you spell scheme. No, that's right. If it's something plus OH, then nearly always, I say, always use base naming scheme. With very few exceptions. The only exception I can think of is, let's add one more weird example. What would happen if we add hydrogen with OH? This would be HOH, which is more commonly written as H2O. And what would the name of it be? Hydrogen hydroxide. Again, we mostly call this water. Water has lots of different names. By the way, to really illustrate this, because I love it, I cannot believe they got a city to ban this chemical. The dangers of water. Also known as hydroxyl acid. We don't use this naming scheme in this class, but YL is a special naming scheme. It means something totally different. Or it means it has a HO in it. It contributes to greenhouse effect. May cause severe burns. How can water cause severe burns? Speak up. What if you put your hand in boiling water? Will it burn you? So water can burn you. Yes, it's that stupid. If you put your hand in burning hot water, it will burn you. Again, it doesn't specify burn on contact. It just means that it has the ability to burn. Contributes to erosion of our natural landscapes. Accelerates corrosion and rusting of metals. May cause electrical failures and decrease effectiveness of automobile brakes. Meaning that if it's wet on the road, your brakes are less effective. Has been found in excess or in removed tumors of terminally cancer patients. So this is a chemical that is found in cancer patients who have died. It's used as an industrial solvent. Water is known as the universal solvent. And coolant used in nuclear power plants in the production of styrofoam as a fire retardant. Yes, it can be used to put out fires. It has been used in cruel animal research. They gave their animals water to live. It's been used as a distribution of pesticides. And I like this phrase. Even after washing, the produce was still contaminated by this chemical. You can still find traces of water in the fruit after it's been washed. It has been an additive in certain junk foods and other products. But the entire city banned it for a few days. Alright, let's do some more examples. Some of these we already did, but it's in a table. So, hydrogen and sulfate. This is H plus and SO4 2 negative. So when it crisscross, this becomes H2, SO4. The ratios in the PowerPoint is wrong. I would say this is a 2-to-1 ratio. It puts 1 to 2. So the name of this is sulfuric acid. Potassium and hydroxide. I would like to note also, I said this. For blank and OH, always use base naming scheme. Is the base naming scheme any different from the ionic naming scheme? What is the ionic naming scheme? Write the cation and then put the anion, the name of the anion if it's polyatomic without any change. Then they're the same thing. Base naming scheme and ionic naming scheme is the exact same. There is no change between them. So you really only have to worry about remembering when you need to call something an acid and when you put the ionic. So this is a 1-to-1 ratio. So the formula is going to be KOH. And for ionic and base naming schemes, it's the name of the cation unchanged. So potassium. And then it's the name of the polyatomic ion, unchanged. Or you just put the word hydroxide. The importance, though, is to recognize if you see an OH in the formula, you need to know that it's going to be a hydroxide and it's going to be a base. Hydrogen and bromine. So H plus and Br negative. That's HBr. 1, 1. And so this is called hydrobromic acid. If you put hydrogen bromide, a lot of people wouldn't probably understand what that is because it's very seldomly called anything other than hydrobromic acid. And a lot of chemists actually memorize the names versus the formulas. Or they more think of it in terms of names than formulas. So phosphite, phosphite would mean one less oxygen, so it's normally PO4. So this would be PO3, and that has a 3 charge. And hydrogen plus. So doing the crisscross, we need 3 hydrogen to counteract this. So this is a 3-to-1 ratio. So ite, we do the opposite when converting it into an acid. So this would be hydro phosphor. So it's ite, so we do OUS. If it's 8, then we do the ic. I like remembering that we do the opposite. And then aluminum and hydroxide. Al is going to be 3 plus. Hydroxide is always OH negative. So the OH is going to get 3. So this is a 1-to-3 ratio. And we just write down the 2 names unmodified. And there should be a U in there. Seems simple enough. So, percent composition and empirical formulas. A lot of times when we're trying to figure out what a chemical is, we need to know the percentage of the elements in it and to figure out what the empirical formula is. So if you are ever doing any sort of chemistry where you don't know what chemical is in something and you're trying to find the chemicals, this is the type of science you do. So, for example, if we have some chemical, we know that it weighs 50 grams, and let's say that we do some chemistry on it and we remove all the oxygen from it. So we break off the oxygen and we're left with 5 grams of sodium and 10 grams of chlorine or something else. And that means that the gas would have been 35 grams of gas removed. This means that we can use molar mass and figure out what ratios of each chemical went into that formula, and we can make some educated guesses what the formula for that chemical is. So the percent composition is the percentage by mass for each element in that compound. The percent composition is found by using the following formula. The total mass of the element divided by the molar mass of the compound. I would say the total molar mass would have been a better use to write in this. What I mean by total molar mass is if there's two hydrogen, then you would take the molar mass of hydrogen, which is 1 point something grams per mole, and you multiply it by 2. Overall, it's very intuitive what it means when you see some examples. So, what is the percentage of carbon and hydrogen in C2H6? So, C2H6. We have 2 carbon. So we would do 2 times, looking at the periodic table, and then we do 6 times hydrogen. So 6 times 1.00794, and add them up. I recommend doing this. Write the partial sums next to it. And then when we add them up, we get a total of 30.06904. This will be grams per mole for all of them. So the percentage of carbon, so percent carbon, would equal 24.0214 divided by 30.06904. Which is 0.798875, and written as a percentage, that is 79.8875%. Now, since there's only 2 elements, you could just do 1 minus this number, or you can recalculate it. You can only do that method if there's only 1 left. So now we use hydrogen, 6.04764 divided by the total mass. And that would equal 20.1125%. Let's try water. H2O. So there's 2 hydrogen. So 2 times 1.0794. And there's 1 oxygen. So 15.9994. Which would equal 2.1588. And the total sum is 18 point something. .01528 grams per mole. So the percentage oxygen would be, so the percent oxygen would equal 15.9994 over 18.01528. Which is 88.81%. And the remaining percentage, the percent hydrogen, would thus be equal to 11.19%. So water is 88 almost 90% oxygen and only 10% hydrogen by mass. Even though there's twice as much hydrogen in it. Depends on what you mean by twice as much. If it refers twice as much mass, you'd be wrong. if you meant molecule or atoms, then you'd be right. So here we see 29.89% carbon and 20.11% hydrogen. So here's another example. What is the percent of each element in sodium sulfite? They do a slightly different method. Or I shouldn't say, they actually spell it out and use dimensional analysis. So there's 2 moles of sodium. I just do grams already to start it. I don't remove the per mole. They like to remove the per mole of it so we get grams. Because we are trying to do percent mass and not percent molar mass. So they multiply it by moles. There is 2 moles of sodium for every 1 mole of sulfur, multiplied by 3 moles of oxygen. I like just keeping it in terms of molar mass, and I get grams per mole on the right-hand side. And they're technically wrong here anyway, molar mass. I just realized I have 2 sodium, so I multiply it by its molar mass, and I get 45.980. Add it all up, and you can find sodium, sulfur, and oxygen by doing the same thing. Molar mass is supposed to be in grams per mole. It's a ratio, not a true mass. Does that make sense? So what is an empirical formula? An empirical formula is the lowest whole number ratio of the elements in a compound. The subscript cannot be a fraction. So for ionic formulas, the empirical formula and the ionic formula are the same thing. For at least the non-polyatomic ones that don't have polyatomic. For covalent, they'll be different. We'll go into that tomorrow. So H2O2, hydrogen peroxide, we can divide that in half and make that HO. HO would be the empirical formula.